All right, friends, we are going to do some practice problems here. Let's do some circulation problems with Green's theorem. So first of all, remember, when we look at our original problem, the original problem is going to be set up where there is a function p that's attached to a dx, and then it'll be plus q dy. So we're looking for those pieces. Whatever's attached to the dx is going to be the p function. Whatever's attached to the dy will be the q function. And so then when we set up using our Green's theorem, we're going to set up this way. So we have q with respect to x minus p with respect to y dA. That's how we set that up there, my friends. So let's look at one of the problems in the text that I gave you. It looks like this. It's 2xy dx plus x plus y dy. It's like that. So then, and let's do this from, let's make this simple. In fact, I think what we're going to do for all of our problems here, we're not going to do any of the complicated ones. We're just going to do them from points here, like over rectangles and stuff. So we'll go from the point 1, 1 to the point 2, 3. Those will be the cross bounds of a rectangle. So then we have a width of 1 and a width of 2 there, a length of 2. So just to make sure we know what we're doing, we want to make sure we identify what is our function p. And in this case, our function p is right here. So our function p is this 2xy. And then we also want to say, well, what's our function q? Then that's right here. It's going to be x plus y. Then we're going to take the partial of p with respect to y. And so we hold the 2 and the x, those are variables, and the derivative of y is 1. So then this would be 2x. When we come over here, we're going to take the partial of q with respect to x. Well, this is a plus, right? So the y just becomes 0, and that just becomes 1. Would you agree with that? So then we can plug all of this into our double integral here. And we can vary the way we do this, but let's do the x's first. So if I look at the x's, I'm going to go from 1 to 2 right here. So from 1 to 2. And then the y's are going to go from 1 to 3. And my function is my function is going to be qx minus py. Oops, right there you can't see it. Qx minus py. Here's the qx minus py. Qx minus py. And then we'll do the dx dy because we put these x bounds in first. So here's what we're looking at. And then we're going to go from here. We're going to say, all right, let's look at that inner function first, which is this, right? And then the integral of that with respect to x is going to be x minus 2x squared over 2. Well, the 2's cancel, right? And so then wouldn't I be left with x minus x squared? So I'm going to move that to another page here. Let me slide this down here so we can see what we're doing. So we've got x minus x squared, and we're going to evaluate that from 0 to 1. That's our function there. Oh, I'm sorry. I said 0 to 1. It's not 0 to 1. It's 1 to 2. I apologize. So we plug in the 2. I get 2 minus 4 minus 1 minus 1. So 2 minus 4 is negative 2 minus 0. And so my answer is negative 2. So that's my answer for my interior integral. Then I'm going to say, well, then I'm going to integrate from 1 to 3 of negative 2 dy. I can pull the negative 2 out. And it looks like this. Well, that becomes y. I'm going to evaluate that from 1 to 3. So that becomes negative 2 times 3 minus 1. 3 minus 1 is 2. Negative 2 times 2 is negative 4. All right, friends, let's look at one more example. let's do same thing. We'll still do circulation. So let's look at y cubed dx minus x cubed y squared dy. And remember that this is our p. So let me just make a note of that. So we're remembering, oops, that's not an x. And our q. And notice this is a negative here. So that means we're going to have to say that that's a negative x cubed, because it's plus, right? And it's px plus qy. And so then let's make sure we remember what we're looking for here. I'm just going to make a note. It's qx minus py, right? And let me see. We got some bounds here. We're going to go 0, 0 to 3, 5. All right? And then what we need to do is we need to say, well, I got to find my py. This is y cubed, so that would be 3y squared. And then I need my q with respect to x. And so I'm going to take the derivative. Well, the negative comes down for sure, right? So this is a negative 3x squared y squared. All right. So then I'm going to plug that in here to my qx minus py. So I'm going to get negative 3x squared y squared minus 3y squared. And you could certainly say, oh, we can factor and factor. Yep, whatever. I mean, you could certainly do that if you want to. But we're integrating this, so let's just integrate it. We can do whatever you want. Let's just do the x's first. So we're going to go 0 to 3, and then the y's are 0 to 5, and I'll put the dx dy. So let's look at the x's. So we're going to integrate this with respect to x. So wouldn't that be negative 3x cubed over 3 y squared, because the y doesn't do anything. And this, with respect to x, doesn't that just become negative 3x y squared, because this is all just, we treat that as a coefficient, right? Well, notice here the 3's can cancel. So then I have negative x cubed y squared minus 3xy squared. And we're going to evaluate all of that from 0 to 3. The 0 part, it's not going to matter because they're all going to turn 0. So we just need to plug in 3 there, and for the x. So it looks like this becomes negative 27y squared minus 9y squared. Oh, hey. Hey, can we simplify that? Can we do something with that? Let's see. We can combine these now. These are like terms. So a negative 27 minus 9, that seems like negative 36y squared. Hey. All right, then we'll come over here and we'll take our negative 36y squared. That was our answer. Now we're going to plug that into our, let me just rewrite this for us as we're on a new page here. Well, let's go ahead and pull out that negative 36. And we'll integrate. So then I'm going to say I've got negative 36 times y cubed over 3 evaluated from 0 to 5. We can simplify this first if you'd like to here. That becomes negative 12, right? So negative 12y cubed. That's what that turns into. And we're just going to evaluate that. Well, 5 cubed is 125. The 0, again, is not going to matter. So it's 12 times 125, and that is negative 1,500. Not too bad. So those are some examples of our Green's theorem with the circulation.